In this session we will talk about the M1's terminal layout and hookup. You may follow along in the installation manual on pages 6 and 7. All the terminals on the ELK M1 are unpluggable. These can be unplugged, wired, and then plugged back in. So all the terminals all the way around the board are unpluggable. We'll start our discussion up in the upper left corner of the M1. The first 24 terminals are for the M1's onboard zones 1 through 16. Each zone can be configured as either a normally open, normally closed, or end-of-line resistor supervised zone. One additional zone type is an analog input zone type, which can be used in the rules writing of the M1. So each zone is common to a negative to the next zone. So you have the zone input negative and the next zone input, which is common back to the center terminal negative. And that goes down to the last zone on the board, which is zone 16. It can be configured as a two-wire smoke zone, and when you configure it as a two-wire smoke zone, the jumper on the board here must be moved to the inside position for a two-wire smoke zone. Also, the end-of-line resistor will change to a 680 ohm end-of-line resistor as described on the label here on the M1. Between the terminals here, there's a light emitting diode indicator for the telephone line has been seized, and right below that there is a light emitting diode for the dialer is active. This is described here on the label. The next group of terminals are the power supply terminals for the M1. The first two terminals is the switched auxiliary power for smoke detectors. And the next group of terminals, as described here on the label, is auxiliary power for keypads or other devices that are needing power from the M1. The M1 has a 2.5 amp switching power supply, and these outputs are have PTC overload protection. They're rated at 1 amp for the smoke power output, and 2.5 amps for the other auxiliary outputs. The last two terminals here are for the plug-in transformer, which is 16.5 volt 45 VA transformer that plugs in the last two terminals. You have a power on-off switch here at the bottom left corner. When you turn the power off, then all the power to the M1 is disconnected, including the battery. There's also another group of LEDs over here. The first LED is the power LED, which will be illuminated when the power or AC power is applied. The next LED is the status LED. In normal operation mode, this LED will be blinking approximately 1 blink per second. The third LED down here is the reverse battery lead LED. So if the battery leads are reversed when you hook them up, this LED will illuminate. Another thing to note here, there's two solder pads on the lower left corner of the board. If you connect the battery to the M1 and do not connect AC power, and you turn the power switch on, then you will need to short these two pads together so that it will override the low battery cutoff and turn power on to the M1. As we move on around the board, move to the lower right corner, there are two temporary data bus connectors here for connecting to devices that might be set up for test on the data bus. The next connector is a 5-pin connector. The first terminal here is earth ground. The next 4 terminals are for the RS-485 data bus. First one being negative, then the next one is data B, then data A, then plus 12 volts. So this is where you'll hardwire your keypads, output expanders, input expanders into this terminal. The next connector here is for two-way listen-in and for a audio network interface that cable plugs into this connector. The next set of terminals here is for outputs. The first 2 terminals is for output 1, which is a voice and siren output generally used for indoor speakers. The next 2 terminals are for output 2, which connects to a speaker. It is siren only. Generally you'll connect output 2 to outside speakers. This outside speakers here can be delayed while the output 1 comes on to give the people inside a premise pre-warning before the outside speaker triggers. The next 3 terminals is a Forum C contact for a programmable relay. This relay can be programmed to do pretty much anything we need to do in the system, and is programmed through the rules programming. The next connector here is a J16 connector. Here again it uses a plug-in flying lead connector, and all these outputs are programmed from the rules programming as well. The next connector here is the X10 telephone style connection. It uses the PSC05 or PSC04 X10 wall plug-in that connects in here through a telephone type cable. And also going along with that, we have the JP2 connector here that selects a one-way or two-way operational mode of the X10 interface. The next connector here is a 9-pin RS-232 serial port connector. This is connected to a laptop PC for programming the M1, or it can be connected to a home automation computer. It may also be connected to our Ethernet interface for getting on the Ethernet. The next connector behind that is for the ITI Cadix receiver. This can be an NX408E or an NX416E or an NX448E radio receiver. The next connector is for the telephone. The first 2 terminals are for tip and ring. That's the outside telephone line. The next 2 terminals are for the inside telephones, T1 and R1. You want to always connect the inside telephones to the T1 and R1. That way, whenever the M1 needs to call the central station, it will disconnect the inside telephones and disable them. One other jumper on the system, if we take the cover off, is the JP3 terminating resistor jumper. If the M1 is at the end of the RS-485 data bus, then you will use one of the black jumper plugs that's in the accessory pack here. That black jumper will plug onto this JP3 connection to properly terminate the RS-485 data bus. So this is the end of the terminal layout and hookup.